Day to Madam Zalila Othman. My name is Shirley Hangwedi and my matrix number is 277597. I'm from semester 1 of Bachelor of Science Economics and student from Group B of Introduction to Mathematics Economics. Today I will be presenting the final assignment of this course. Without further ado, let's get started. The question given in final assignment is, my company can produce at most 120 units of handmade shoes labeled perfect fit each year. The demand equation for perfect fit is P equals to x squared minus 100x plus 3200, where P represents price and x represents quantity or units produced. Now the average cost function given is C equals to 2 over 3 x squared minus 40x plus 10,000 divided by x. For the first part, there will be 4 questions. For the first question 1a, find the total revenue function R. So revenue function R is calculated by multiplying price with quantity. In this case, we will be using the P function multiplying the x. Therefore, P function x squared minus 100x plus 3200 times x. This will give us revenue function of x cubed minus 100x squared plus 3200x. Next, 1b, find the total cost function C. In this case, we are given only the average cost function, which can be known as the total cost function divided by x. So by moving the x to the other side, we can obtain the total cost function equals to the average cost function multiplying the x. Therefore, we use the average cost function 2 over 3x squared minus 40x plus 10,000x multiplying x. This will give us the total cost function of 2 over 3x cubed minus 40x squared plus 10,000. Question 1c, find the total profit function, profit. For the profit function, we can determine by using the revenue function subtracting the cost function. So for the revenue function would be x cubed minus 100x squared plus 3200x minus bracket 2 over 3x cubed minus 40x squared plus 10,000 bracket. By using the bracket, we can easily determine the negative sign or the positive sign while we're doing the calculation. In this case, this will give us the total profit function of 1 over 3x cubed minus 60x squared plus 3200x minus 10,000. Next in 1d, determine the output level that will maximize profit and the amount of profit obtained. So we'll be using the profit function to get the first derivative function, which will be p prime x equals to x squared minus 120x plus 3200. So by setting the function p prime x equals to 0, we will obtain x equals to 40 and x equals to 80. Therefore, the output level that will maximize profit is 40 units and 80 units. And then we will use the amount of profit obtained, which is x equals to 40 and x equals to 80, into the profit function. So my company will realize the maximum profit that can be obtained by producing 40 units of handmade shoes is 43,333 and 33 cents. And while producing 80 units of handmade shoes would be 32,666 and 67 cents. Next, to part 2, there will be 6 questions. In this section, we'll be using the profit function. Therefore, to find the y-intercept, we will set x equals to 0. So by substituting the 0 into the profit function, we will obtain negative 10,000. Therefore, y-intercept equals to negative 10,000. Next, question 2b. Find the intervals where the function is increasing or decreasing. In this case, we'll be using the p prime x function, which is x squared minus 120x plus 3200, and we set the p prime x function equals to 0. Again, we will obtain x equals to 40 and x equals to 80. So this is the simple line graph, which will allow us to determine the intervals of the function, whether it's increasing or decreasing. So in increasing, the intervals would be 0 and 40 union 80 and 120, whereas the intervals when the function is decreasing would be 40 and 80. Next, question 2c. Find the intervals where the function is concave upwards or downwards. In this case, we will find the second derivative, which we obtain is p double prime x equals to 2x minus 120. So by setting the p double prime x equals to 0, it gives us x equals to 60. So we consider the intervals equals to 0 and 60 and 60 to 120. Therefore, p double prime x is smaller than 0 when x is smaller than 60, so p 0. So p is concave downward on the interval of 0 and 60. Whereas p double prime x is greater than 0 when x is greater than 60, so p is concave upward on the interval of 60 and 120. Next, question 2d, find the inflection point. In this case, we'll be using the second derivative function, p double prime x, and then we set double prime x equals to 0, which again we obtain x equals to 60, and we substitute it into the profit function. This will give us 38,000. Thus, the inflection point is 60 and 38,000. Next, question 2e, draw a graph of the profit function using information obtained from 2a to 2d on your graph. Also show the absolute maximum, absolute minimum, relative minimum, and relative maximum points. Based on the graph I've sketched, it started with the absolute minimum point with the interval of 0 and negative 10,000. Next to relative maximum point, which is 40 and 43,333. And next to relative minimum point with interval of 80 and 32,667. And then to the last absolute maximum point with 120 and 86,000. Next, question 2f, label your graph and write all important coordinates and intervals. In this case, I've labeled the increase and decrease flow of the function, the concave downward and concave upward of the function, and the absolute minimum is representing y-intercept, and then the interval of within 0 to 120. So that's all for the presentation of this final assignment. Thank you for watching and have a good day.